So this is the overview of ZTNA connector from the Strata Cloud Manager. And for the log view here, as I told you, so it is trying to load. Okay. So what you can do is log source. Just keep it here. Log source, and then equal to, we can select PA underscore CONN. So this is the first filter you should consider using when you want to identify what is happening with your traffic. So immediately you saw the flows get filtered with the subtype net flow. So these are traffic initiated from the agentless access going towards this destination, and this is the port. So if you put in for last, okay, let me filter by source address, and I'll try to give the GP address 10.10.20.2 slash, and then search. So last 10 hours. Okay, I have some flows here. So this is the GP user trying to access the anycast IP of the app1.fqdn.local. The action is allowed. So when I click on the session, I do see that the the information I shared with you on the slide deck. This is the source address of the GP user. This is the NATed IP of the connector IP, and this is the destination IP, which is the anycast IP of the app, and this is the destination IP to which it gets translated, which is the actual IP in the physical data center, okay, or the cloud. Now, if I go back here to configuration, ZTNA connector, uh, connectors, and this connector, right? Sorry, go here and I click on the diagnostic tool and put dump overview and select. So just to clarify that this specific IP which we were looking for, the source IP 10.55, how do I understand that this is part of the connector IP? So when you look at here, the interface, the physical interface port 1 is configured with 10.55. So this is the IP which uh, replaces the source IP of the GP user, and then the connection is initiated towards that server. Okay, so knowing this info and then reading these logs correctly will greatly help you to understand how things work in the network. Okay, so this is the logs, this is for the FQDN, and this is for IP subnet. So if you click on this, this is the GP user connecting towards 10.1. Okay, no, this one, I'll select the other one. This 10.10, I think the destination is 10.10. And I'll remove this source address. So this is for the IP subnet access. So if you look at here, this IP gets translated to 10.55. Destination remains the same for the app, for the IP which we are trying to access from the ZTNA connector, through the ZTNA connector. So these are the two main targets. For wildcard, we discussed how it works. So this is a short demo about how the ZTNA connector is configured and the logs are viewed. Tomorrow we'll deep dive into the monitoring tools as well as more about the troubleshooting, like how to understand the tech support file, how to read it, how to um, troubleshoot with the logs we have from the tech support file, and what could be the possible issues. What are things to consider? What are the best practices to use? We'll do a deep dive tomorrow on that one. Okay, so now let's get back to the presentation. Okay, so now we will touch base into we had a complete life cycle of creating, getting the template, deploying it in a hypervisor, onboarding the ZTNA connector, understand the different phases of onboarding, configuring an app, testing the app. We tested an FQDN target. We tested the IP subnet target. We saw how a wildcard target is defined. So now we'll see how the same concepts apply, but a little bit. Uh, the source of the template is a marketplace, and we use the cloud vendor to build the ZTNA connector inside the cloud environment. So we'll run through the three common supported um, cloud providers. We have support for more cloud providers, but in this session, we just touch base into uh, AWS, Azure, and GCP. The biggest key strength about this cloud-based ZTNA connector deployment is auto scaling, which is available in AWS as well as in Azure. Okay, so ZTNA connector deployment in Azure, we log into the marketplace. We have the permission to download the solution template. We choose whether we need a one arm or a two arm deployment with or without auto scale, and then we need to define we in Azure it's called the set, the template it's called set, and we need to determine whether we need to have auto scale or not. Okay, and here is some screenshots taken up from the template screen of the Azure. I do not have access to Azure to show you, but we have some snapshots taken for one arm, two arm, one arm auto scale, and two arm. So when you're considering an auto scale, so you can define that you need at least a minimum of two connectors, so that you don't end up in a situation when it scales down to and removes all the connectors, right? So we need to have at least two connectors, so that, as I mentioned to you earlier, we have redundancy. We have multiple IPsec tunnels to depend upon to connect to the Prisma Access infrastructure, so that users can access the private apps. And then we define the resource group, define the region, and one caveat for the auto scale: initially the region is not selected. It will show as unknown region, but once the connector is spinned up, you will see the region. And next one is the configuration of LAN or WAN subnets. Define the VM name, the LAN interface, add the key and secret which we generate from the Startup Cloud Manager. And there's a random VM secret. There's no use for that, but it's mandatory to be defined. What we have is a default login user credentials, which is used to access the initial connector boot up, when the connector boots up, to log in into the connector and see what's going on, in case the connector doesn't auto onboard. But this random secret is more of an Azure component. It's not much of use for this one. Finally, review and create the connector, and it's whatever we discuss about downloading the application and all the targets, everything applies to the to this deployment also. Okay, the only differentiation is the getting the template, and the source of the template is marketplace, not the support portal, and choosing which one we require to configure inside the cloud. Next one is the AWS deployment. Similar to Azure, we have a AWS marketplace. We pick the template, we choose the deployment model with or without auto scale, select the region, configure the LAN and WAN subnets, whatever is necessary, and review the config and install the connector. For GCP, again, these are the snapshots taken, how you uh, ex- the same process applies to GCP also, and and you need to generate the token, secret, and key from the Startup Cloud Manager and apply it here when you want to onboard your ZTNA connector in GCP environment. So the connector demo, um, we already saw a demo. We have a recorded one of that. We'll just run through it. So this is just to, in case the demo didn't work, to have a backup plan. So still we can watch it out. So this is a connector group created, and we have connectors created. You can see that the version number is 623. It's a little bit old video, but we can use we can upgrade the connectors from the Startup Cloud managers if required. We have wildcard targets. We have FQDN targets. IP subnets. So within the connector tab, yeah, yeah, this is more on the monitoring. We have the Azure server. We'll discuss these options tomorrow in detail. How to monitor the connector from the new layout of Strata Cloud Manager. So this is the previous layout. We'll go in depth on this tomorrow. These are the FQDN apps. These are the connector group to which these connectors are configured and the apps are defined. For the navigation, from Strata Cloud Manager, whichever is convenient to you, you can access from the insights. You can go back to the configuration. From the configuration, you can view the diagnostic tool, vice versa. So you can play around with the Strata Cloud Manager, whichever style is works with you. You can use that. So this is the previous layout. And what I just showed you in the live demo is the current Strata Cloud Manager. The configuration for workflow is being replaced with configuration, and monitors replaced with insights. That's the major change we have. So these are the four tools we discussed already. Um, this would be generating the output for dump overview. A minimum of this dump overview and the tech support file will attaching to the ticket would greatly help in understanding the problem and supporting from support perspective. So this is the output. We already seen it in the live demo. So this is the tech support window. This is the packet capture window. We can define filters here, source or destination IP, protocol, which protocol you want, or you can capture all traffic. And once you start it and stop it, you will have the file generated and you can download it from here. Okay. So majority of the stuff we already have seen in the live demo. So I'll just stop this one and go back to the slide. Okay. So the next feature we're going to look at is the user ID support with ZTNA connector. This is a special use case. We have more information in this link. You can refer to it. The copy of the slide deck would be shared in the live community. Um, Here, what happens is the user base policies are applied when the traffic is entering the Prisma Access infrastructure. And if you want to extend user base policies inside the data center, then if you have a PAN-OS firewall, we have a support for this through this. When this firewall is the next hop for the ZTNA connector, we use a Jenny protocol to pass the user information in addition to the traffic that needs to be forwarded to the app server, and we can apply policies based on the user who's connecting for the app he's trying to access at the data center with this information. At the same time, the user information is redistribution, user ID redistribution is allowed from the NGFW to the ZTNA infrastructure, and we can use it. We saw the option when we define the connector, whether to preserve the connector group, whether to preserve the user ID. So that enables this option to be available. I mean, you need to check that one. So if you go here to the connector group, so when you define a new connector group, you see preserve user ID. So this feature should be enabled only if all the firewalls at the DC are running PAN-OS 11.2 and above. Okay, so this checkbox enables that option to you. By default, it is unchecked, so you can enable it, and when you're creating a connected group. So if the connected group is created without this option, then it will not be allowing you to change it. So, like for example, you have this connected group, and if you want to change the settings, it doesn't allow you to enable it. Okay, all right. So this is with the user ID, the one we showed just now in the Strata Cloud Manager. The native app discovery with ZTNA connector. So AWS allows you to automatically discover application in AWS environment, onboard all the app in a single click, provide secure access instead of opening an entire network, one-click integration with it into AWS with IAM role, and highly scalable. So we have this step-by-step covered in our tech doc. I will include the link here, how to do it. So probably you need to have access and credentials to configure this. Once it's done, we have a discovered targets in Startup Cloud Manager, which get auto-populated once we learn these or discover these apps through the AWS. So this is a feature which eliminates, in addition to wildcard target, eliminates the need for you to manually key in the target. So if you have a large footprint of apps and you want to auto learn it, these mechanisms can greatly help you. And then the last topic for the day is the Prisma Access browser privileged remote access with ZTNA connector. So PRA, in short, allows you to access non-web apps from Prisma Access browser through the EPSPN, which is the method by which the private apps are accessed from the Prisma Access browser. So here it allows your users, especially users who don't have a GP client, who are unmanaged, or contractors, and who want to have an agentless access. At the same time, they want to get into a jump host or a specific server and work. Especially this is very common under medical environment where there are contractor consultants who work for many different health clinics. So they can use this method of access, which is through from Prisma Access browser. The non-web apps from unmanaged devices can be connected using the ZTNA solution, ZTNA private apps access. So here in this screenshot, I have a sample uh, user who has connected to the Prisma Access browser. After he does his SSO sign-in, he sees the two apps. One is for RDP, MS Home PC RDP. Other one is a PA firewall, which is an SSH uh, client to which the user can connect to. So when the user is establishing a connection, so if you notice the URI is PAB PRA with some with an FQDN, which is created, which gets onboarded when the applications are onboarded. Once the app is onboarded, once the connection is established, we can see the RDP session available from the Prisma Access browser itself. So you use the browser through through the PRA and the ZTNA connector, connect to the RDP session and work from the browser as if you're connected to the RDP client. Right? You can disconnect or transfer files to the session. The next one is the SSH session to any of your devices, switches, routers, firewalls in your environment. You can connect to it from to the same method. So the traffic originates from the browser, goes to the explicit proxy, and from there it goes to the ZTNA connector, and the connection is established to the respective app. Port RDP as well as SSH. So we'll have a quick demo. So for this one. Okay, so this browser over here, let me close these sessions. Okay, so you see the two icons here available in the home screen of the user. I've connected to this one. This is the tenant to which I've connected from the Prisma Access browser. So when I click on this link, it will take me straight into the RTP of the machine. Okay, so here it indicates that this connection is through Prisma Access, and this is connecting to, again, the 10 network 10.64 through the IP subnet target. The RDP session is established. Okay, and the next one is the SSH session. So when you click on this, it will ask for login credentials. If you have configured the password manager in the Prisma Access browser, you can You can enter your PIN code and key in the password. Once it's done, you can connect to it, and the SSH session is launched here. If this is the path it's trying to connect, and again, this session is also connected through Prism Access. It's quite secure. Using an unmanaged device, accessing a private SSH session to your network, wherever the ZTNA connector is deployed, whether it's in the cloud or in the data center, and you can fully interact with this. So it's all, and then you have the output available as well as the RDP. You can click on it and work with it. When you're done with the session, you can disconnect and it will close the tab, and you can terminate the session. Okay, so with this, I think we have completed this demo. Do you have any question and answer you would like to ask? I'll stop sharing.
Yeah, this has been absolutely fantastic. Thank you. Yeah. Looks like we've got all the questions answered so far. Jiteka's been right on top of everything naturally. Yeah, everyone, if you do have any other questions, now's the time to get them in. We're wrapping up in just a moment here.
You can enable Chintaka to speak, Charles.
Sure, I'm happy to do so. Yep. All right.
And tomorrow we'll focus
on you there. Yep.
Tomorrow we focus on the monitoring and troubleshooting and the best practices for ZTNA connectors. It could be relatively shorter than this one, but we covered the core items in the agenda. We also had a lot of demos. We saw all the different ways of accessing the private apps from IP target, FQDN target, as well as the Prism Access browser, agentless access, agent-based access, remote desktop, SSH, web app. So we almost covered the demo of all the major parts of ZTNA solution of Palo Alto Networks.
That's fantastic. Chitaka, did you have anything that you wanted to come off mute and add, or?
Nothing specific. Thanks for the questions. Great questions. I hope you got the answers and you got the required responses within the session and the responses. So if there's anything, please feel free to ask. And some of the questions regarding the solutioning, architecturing, we didn't deep dive because they require understanding of your environment, specific scenarios, how your environment has been deployed. So those are questions that we need to have a deeper conversation, and that's why I suggested syncing up with the accounts team. They will be able to get you the right people and get you the right solution in place to make sure that we have built with right redundancy, scalability, and everything in place.
Okay, fantastic. Yeah, we do have one last question. Looks like come in from Sohail. Can we publish similar applications via Panorama GPGW if customer does not have ZTNA?
As of today, we don't have that, but I'm not sure whether you are familiar with clientless VPN option. It's sort of like a app publishing without advertising, the like without giving a separate, something like that. You can use that, but not exactly as ZTNA connector, but that is pretty close to what you might want.
Okay. I hope that answers your question then. So again, because we've had, especially since we've had, we got to thank you. Fantastic. Because we did get so much fantastic conversation in the chat. Once we do publish this event on Live Community, I will be taking the entirety of the chat. It'll be a CSV file that's zipped up. It will be available for everyone to download. I saw there were links in there. I saw there were great questions and answers. All of that information will be available to everyone after tomorrow's event. So we will be getting together again tomorrow at the same time. Gentlemen, I will let you go at this time. So thank you very much, both of you. I have about 2 more minutes of stuff that I'd like to talk about.
Thanks, Charles. See you tomorrow, everyone. Take care. Bye-bye.
Yep.